Okay, in this video, I'm going to basically solve the homework that you were given in week 2 that's due at your week 3 lab. Okay, and so just a couple little things here about this. Okay, you should do this over the transition week and have it prepared and ready to go when you walk into lab on week 3. All right. If you do not have a printer at home, then you should go to Kinko's and get it printed there. Or if you have a neighbor who can, you can email it to and have them print it for you. Do something like that. Be creative, okay? You really need to get this done during the transition week because we're already behind because we did the first 2 weeks online, and you really need to be practicing this stuff. And now you've got this key that's going to show you exactly how to do it. What we're going to be grading you on for this particular homework is, did you do it? Okay, did you make an honest attempt? You made an honest attempt, you're going to get credit for it. If you did not do it, you're going to get a 0. Okay, so anyway, it's really super important that you really start practicing this stuff on your own if you're going to be successful. Okay, great. So first thing I want to just point out to you is that all these little dots on here, these little X's, those represent where a target was, a vessel was on the radar screen at a particular time. So all the information that we've got here, this is a radar transfer plotting sheet, we actually pulled off of the radar. And how this worked is that we started making observations at a certain time, right? So here's our heading line, and we go clockwise around. The very first target we encounter is going to be target 1, then target 2, target 3, target 4, target 5. Now, when we started making our observations, we called it time 0. That's when we began our observations. So all these little X's with zeros are where the target was relative to us at time 0. And then 6 minutes later, we made observations of all those vessels again. And we pulled the range and bearing off of the radar and we plotted it on the chart. You're going to learn how to do this in lab week 3. Okay, we haven't shown you how to do this yet, but we're going to show you in the lab. But what we're trying to do right now is get you practicing plotting and calculating DRM, SRM, CPA, TCPA. DRM being the direction of relative motion. Okay, that's in degrees. SRM being the speed of relative motion. That's going to be in knots. CPA being the closest point of approach. That's going to be in nautical miles. And TCPA, that's the time of the CPA. That's going to be in minutes. It could also be in hours, depending on the plot, okay? So, now, so let's take this target 1, for instance, okay? At time 0, all right, so that's when we made our first observation. We call it 0. The vessel was about, oh, by the way, we're using the 12 nautical mile scale, okay? Our radar was set to 12 nautical miles. So you see there's these scales over here on the side. Get rid of the 6, get rid of the 3 and the 24. We're going to use the 12, okay? So if that's 12, that's 2, 4, 6, 8, 10, 12. So that looks to me like, I don't know, a little more than 11 miles. And the bearing to that target was about 14 degrees. I pluck that off the radar and I can plot it. So the vessel, I'm going to name this R. So all these zeros I'm going to call R. R, R, R. Now all these 6s I'm going to call M. And you're going to see why in just a second. M, 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 M. What that gives us, when I connect those from R to M, from 0 to 6, the target was here, now the target's here 6 minutes later. It's getting closer to me, okay? This target was here. 6 minutes later, it's here. It's kind of getting closer to me. Well, what these two spots begin to create is a relative motion line, okay? And if I draw a line from R through M, and I go past the center, so here's the center, okay? I have what's called a relative motion line, okay? This is the RM line. And that's where all this RM stuff comes from, it's that line. Now, this line has a direction, and it also has a speed, and we're going to calculate those right now. So, first up, what's the direction of this relative motion line? Okay, well, so this line is passing right through the center. And as long as the line is passing through the center, I can just read the direction of the line directly. It's going in that direction, so we're going to be some kind of direction down here. So I go ahead, I put this on there. All right, I get that going like that. And I go, all right, I'll put that right on the line. I go like this. Boom. Looks to me like the direction of relative motion is 190, 191, 2, 3, 4, Yeah, like 194-ish, okay? 194, 195. Now, if you connected your guys like this, you might be up around 200. If you connected your two spots like that, you might be down by 180, okay? What it boils down to is that the scale is, this is smaller than the normal plotting sheet. What we're trying to do is make sure you get the general idea of this. If your numbers are plus or minus 5, 6, 7, 8 degrees, it's okay. You're in the right ballpark. So based on this, I think that the direction of relative motion, okay, is about 194, okay? All right. Now, what's the speed of relative motion? Well, here's an interesting thing. In 6 minutes, the target went from this distance to this distance. It covered that distance. Now, I can actually measure that, can't I? I can take my dividers and go like this, and I can put it on those two spots. Now, this is 12-mile scale, so I come over here, and I can measure that over here, and man, that looks to me like 1 nautical mile. All right, so 1 nautical mile, 2, 3, 4, and then it's broken up into tenths. So so for this target 1, interesting thing here, okay? Target 1, 6 minutes, it went 1 nautical mile. Now, I want to get speed. Speed is in knots. 6 minutes, well, knots is hours. So I need to get 6 minutes into an hour. What do I do to 6 minutes to make it an hour? Well, I multiply it by 10, because 10 times 6 is 60. That gives me 1 hour. Well, so now what I'm going to do is I'm going to multiply 1 times 10. And what do I get? 10 knots. Okay, so the speed of relative motion is 10 knots. The reason why we chose 6 is so that we could use the 6-minute rule, which is something we're right in the center, and we have a CPA of 0. Okay, and that means the closest point of approach. It means in actuality, we're headed to the same point in space. Okay, so now what's the time of the CPA? Well, here now we're going to do the time of the CPA. So to do that, what we're basically going to do is we're going to take the distance, okay, that was in 6 minutes, and we could actually create a proportion to figure out how long, if that took us 6 minutes to go that distance, how long would it take it to go that distance? Anyway, but I can also just walk it down. That's a little bit simpler. So there's 6 minutes. There's another 6 minutes. Wait a second. I got a little mess there. There's another 6 minutes. There's another 6 minutes. Okay, and I can walk these all the way down. All right, and this is going to be a little bit, it's going to introduce a little bit of error, but, it's okay. Okay, so now what I can do is I can say that was 6, 12, 18, 24, 30, 36, 42, 48, 54, 60, and I've got down here, I've got 66. Looks to me like that's around 62 minutes, okay? This is 63 minutes. It's back a little bit, 61 or 62 minutes. As long as you're in that ballpark, you're doing fine, okay? That was target 1. Now let's go to target 2. This was where it was at time 0. This is where it was 6 minutes later. So I go R to M, okay? I go R to M. I draw my line. Great, okay? Now, let's do the direction of this. You might be like, oh, hey, check this out. Yeah, great. Oh, cool. The direction of that is 160. Well, in fact, it's not. Okay, this outer ring with these degrees on it is only valid from this spot. So I've got to transfer this line to the center. That actually looks to me like something more like south. So what I can do here is I can just put my triangle up against there like that. Okay. All right. And I can bring my other triangle in. And then I slide this over. I get to the center. I can put my pencil right in the center, lay that up against it. I go like this. And that looks to me like it's like 181, 182. So as long as you're like somewhere between 170 and 190, you're good enough for this scale. Okay, so I'm going to say this is like 181. All right. Now, what's the speed of relative motion? Well, so what I'm going to do is I'm going to say, well, how far was the relative motion in 6 minutes? All right, so I go like this. I come over here, measure this. Looks to me like that's about 24. So 6 minutes. That's 2.4 nautical miles. 2.4 nautical miles. Multiply that by 10. That gives me 60 minutes, which is an hour. Multiply this by 10. I just move the decimal over. 24 knots. So that's the speed of relative motion. So just move the decimal place over 1, And that's all you have to do. I get 2.4, move it over to 24. Now, what's the CPA? Okay, to get the CPA, what I'm going to do is I'm going to put my pencil right in the middle. And what I'm going to do is I'm going to try and find a line. I'm going to draw a little line through my relative motion line that intersects it at 90 degrees. So it's going to the south. I'm going to intersect it kind of on the east-west. So I put my little pencil down there. Okay, and I can lay my triangle, okay, up against that. Now what I'm going to do is I'm going to take advantage of this nice perpendicular line. I got this edge. This line is perpendicular to it. So I put my pencil down there, put my perpendicular line on my relative motion line, all right, and I can make a little tick mark. Now, if neither one of us changes course or speed, that target's going to continue to kind of follow down along this relative motion line. And this is the spot when it's going to be the closest to us. That's the CPA. So I can measure that now. So I go like this, and I go like this, and I go like that. Come over here, I go like this. Looks to me like that's closest CPA is going to be at 4, maybe 4.5 miles. So I'm going to say 4.5 nautical miles. All right? And that's close enough. You might have, if you drew your line a little bit over this way, you might be more like 5 miles. Over here, you might be more like 4. As long as you're in the 4 to 5, maybe even up to 6 miles, you're okay at this point. No problem. All right, now what's the TCPA for that? Well, we're going to walk that down again, right? Okay, so I go like this, I go like this. All right, and I say, okay, well, that was another 6 minutes, and there's another 6 minutes, and there's another 6 minutes. So that's 6, 12, 18, 24. It looks to me like that's about 22 minutes. So I'm going to go ahead and put 22 minutes in. That's good enough. Okay, now we go on to target 3. So at time 0, the target was right here. At time 6, the target was in the same spot. Now we're moving. We're going north at like 15 knots or something like that. We didn't tell you how fast we're going, but we're going north at 15 knots. So that means that vessel would be back on your quarter. Well, 6 minutes later, it's in the same spot. It's going same course and same speed, isn't it? Okay. So what's the relative motion, though? How close to it since R and M are at the same spot, there is no relative motion. So this is a vessel. This is a special case. This is a vessel that is same course, same speed. So what's the speed of relative motion? Well, if it's not moving relative to us, there is no relative motion. There is no relative speed. Now, what's the CPA? Well, the CPA, it's happening right now, isn't it? It's happening all the time. So the CPA is this distance. So that looks to me like it's about 6 miles, 2, 4, 6. Okay, 6 nautical miles. That's great. What's the time CPA? Well, it's now. It's now. It's now. It's now. Heck, it's now. Okay? All right. It's always. Okay? So I could say now, I could say infinity, anyway, whatever, because I'm always at that CPA as long as neither of us changes. All right, now we get over to target 4. So now this vessel here is probably is maybe dead in the water, or it's on a reciprocal course. All right, this vessel here was same course, same speed. This vessel here, you might think it's going this way, but it's actually going more westerly, right? And we're actually headed to the same point in space. You'll learn more about that when we do the lab. What this is telling me back here, though, is that this vessel is going faster than us. It was here. Now it's coming up our port side. It's overtaking us. This is a classic example of overtaking. So what I'm going to do here is I'm going to draw my little line there and go like that, past the middle. There's my R, there's my M, right? I can take this, and I bet you that's going to be something about 0, 0, 0. All right, I'll bring that off to the center. Yeah, okay. So I had that was about 0, 0, 2, okay? So as long as you're between 350 and 0, 1, 0, you're doing fine for today, okay? What's the speed of relative motion? Well, the speed of relative motion is going to be like this. There it goes up like this, all right? And you go like this, and it looks to me like that is in 6 minutes, 2.7 nautical miles. So that's times 10. Anyway, so now, we don't really even need to do this times 10 stuff anymore. All you need to do is just move this over 1. That's 27. So there we go. So the speed of relative motion is 27 knots. Okay. Now, what's the CPA? Oh, yeah, I got to do that thing again where I put my triangle down. I put my pencil right in the middle. I lay my triangle against that. I use this little perpendicular line. I get it on my relative motion line. I get it all nice. I go bang. Okay. And off we go. And there's another way that I could do that as well. Okay, I could actually put my point right in the center, right? And then what I could do is I could swing arcs until I just touch that line tangently. That's another way that I can figure out where the CPA is. It's right where that tangent spot is. But anyway, what is that distance? I bring it over here. I go like this. I put it there. It looks to me like that's about 3 nautical miles. Okay, so I'm going to put 3.0. As long as you're like 2.5, 3.5, you're fine. Okay, for today. All right. And what's the time of the CPA? Okay, so I got 6 here. I got 12. Oh, it looks like it's about 12 minutes. 12, maybe 13 minutes. I'm going to say 12. Okay, so that's cool. Great. All right. So if you're like 10 minutes, 10 minutes, 11 minutes, 12 minutes, 13 minutes, 14 minutes, you're doing fine for today. All right. Last target, target 5. Now this vessel was way up on my bow. Now it's coming down my port side. This is a vessel that's going southbound. You'll learn more about how you can figure that out later. But as of right now, that's enough. All right. So this is a vessel, okay, that's on a reciprocal course. All right. Now let's do our little calculations for that. All right. So I did this. All right. And when I bring it over here to the center, I get, oh yeah, that's 180. Okay. Now, as long as you're between 170 and 190, you're okay. Better to be like 185 to 195, but you should be getting something right about 180. Okay. What's the speed of relative motion? Well, the speed of relative motion is, all right, I measure the distance. I go like this. It looks to me like that's about 4.5-ish or so. Okay, what do I got? I got from there to there. Oh, that looks almost 5. That's about 4.8 nautical miles. So I just go, I move the decimal over 1, it's 48. Okay, 48 knots. What's the CPA? Heck, I don't even have to do it. It's just touching that 2-mile ring. That's 2.0. And what's the TCPA? All right, so I go like this. I go like this. I walk it down. 6, 12. Okay, so that was 6. This is 12. This is 18 down here. Looks to me like that. This would be halfway 15. Looks to me like that's, I don't know, 13 or 14. You can choose either one. I'll go ahead and choose 13. Okay, and there we have it. All right, and that's how you do that. The whole point of this particular exercise this week is to get you into practice of manipulating these things. We're not so concerned, as long as your answers are in the general ballpark, that's fine. You're going to get full credit, all right? But you've got to do this before the lab in week 3. Otherwise, we're going to fall farther behind. Thanks.